Hey there and welcome back to the C# for Total Noobs training. In this part we will go into a topic that it might seem easy at the beginning, and this topic is strings. And I can assure you that strings are not as easy as they seem, and especially at the beginning or at the early stage of a software developer's career, there might be some misunderstanding regarding strings. So that's why we will start this part by having a brief look or brief theoretical look onto what a string is and why it actually is so special, and from where we could have some misconception around strings. So let's get started directly with it, because then I want to go over to Visual Studio and just play around with strings a little bit. So the first very important thing is that strings actually are a reference type, but they somehow or they might seem a little bit similar to value types. And why I say this is because, at least once again, at the early stage of a software developer's career, you might be tempted to say, hey, strings are very similar to integers, for instance, or similar to decimals or doubles or date times. You just have this keyword string that you would use, and well, everything should be fine. It's really, really similar. You provide a string and that's it. But this is actually not true. And the fact that they might seem similar at the beginning from the syntax perspective, this is really something that is leading you in a totally wrong direction. So once again, strings are reference types, not value types. Now, from this fact that strings are reference types, there are, of course, some consequences. So the first thing is that, strings are of course stored then on the heap because they are reference types. But on the other hand, there are some other very important characteristics to strings that you actually really need to know, especially if you go to your first interview. And the first thing that we would need to know about strings is that a string object contain actually an immutable sequence of characters. And we'll see just in a few minutes, it's not just a sequence, it's actually an array. And we will look into what this actually means after this one. But let's take a while on this concept that this string is immutable, because already in our parts of the training that we already use strings without defining them very, very exactly, you might be tempted to say, okay, but we can simply then create a string and then assign to that specific variable another string value. And we have changed the string. Now, this might seem to you like this when you write the code in your editor, but what really happens in behind is then whenever you try to assign a new value to a string, it actually creates a new string. So it's not the old string that you actually modify, but you get a totally new object with the new resulting value. So this means that the new resulting string will have a totally different reference than the string that you had initially. So, and this might, this might be a place where some bugs might come in if you are not aware of this subtlety. But once again, whenever you perform an operation on a string, like for instance, you remove characters, you add characters, you trim the string, you concatenate two different strings. So whenever you do an operation that kind of changes the original string that you have, you always actually get back a new string object with a totally new reference. So it's not the old one, it's a totally new one. Of course, another very important characteristic of string is that they also use Unicode to support multiple languages and alphabets. But this is a topic that we won't dive into very deep right now, because here the discussions are more complex about character representations and different alphabets and character sets, and what problems might there be, and how do we do translations, or how do we write things in the database, and similar stuff. So we might talk about this in a while when we have a more solid understanding of the basic C# language and of course the .NET ecosystem. So let's move on to the next theoretical aspect, and as said here, that the strings are a sequence of characters. Now, it's not just a sequence, as said, but it's actually a real array. So a string, once again, is an array of characters. Char is a data type in C#, And the string is actually an array of chars. So when you have a string, actually each character in the string is actually a char element in a char array. Now, from this fact, there are other things or characteristics that emerge regarding the string, which are very similar or actually the same with the characteristics that we have talked about when we discussed arrays. And the first one is that they have a fixed length. And that's actually the reason why they are immutable, and you cannot just simply then add something to a string or concatenate a string, and you just can't do that because they have a fixed length. And therefore we also have this length property on the string, like we have also on array. So when we have a string, we can very easily find out how many elements or how many characters we have in the string by simply calling or using this length property that we have on the string class. Then another characteristic, of course, as it is the case for arrays, we can access elements directly by the index and using the indexer operator. So this means that we can actually access each character of the string by the index on which that character actually resides, or by the position on which it resides. And this also means that we can that actually strings are, I would say, open to be used in loops. So we can use strings with for each loops. We can even use strings with a for loop, because we can use the I as an indexer to access a specific place of that specific string. And yeah, of course, the length of the string or the value of the indexes, just like we have seen when we talked about arrays, is that they are from 0 until the length of the string -1. And if you are not fully aware why this is the case, why the last element is actually on the index length -1, then just please stop this video and go to the part where we talk about arrays, because in that video we go a lot more deeper into why this happens. But for now, just have this as a conclusion. The idea is that the last index or the index of the last character in a string is always on the index length -1. And yeah, that's actually for the theoretical part. Let's get let's go over now to Visual Studio and let's play a little bit with some strings. So let's have here a new string. Let's call it string1, and let's make it a very special string. What I want to do here is I would like to combine uppercase and lowercase letter in this string. So we have basically written hello world, but with the main difference that in this case we have used different casing for different letters. So from this point on, we can see, for instance, let's have int the string length, and this is our string and the property length. As I told you, string is an array of characters, therefore we have this length property, and we can use it actually wherever we want. So in this case, we can just simply console write line, and let's go with the line, because there will be several things that we want to write on the console here in these exercises, and that should be it. Now, when we calculate the length of the string, or when .NET calculates the length of the string, there is one thing that you have to take into consideration. In this case, it seems that we have 12 characters. When we count the characters, it's important to know that we also count the white spaces. White space is a character, and as said, a string is an array of characters. So this means that everything that we have actually here in these columns, it actually means that it is a character. So also the white space. So white space needs to be counted when we count the length of the string. Now, what can we also do here is, as said, that strings are actually available to be iterated over. So what this means is that we can actually, for instance, use a for each loop, and we can see for var let's make it a char is a keyword, so we can't really use it. So for var, let's call it letter in str1, which is our string. And in this case, let's just console write line. And if you go over with the mouse here on this one, but let's also type it correctly, later it should be like this. So if we hover the mouse here, we can see that this is of type char, because when we iterate through an array, we get each element of that array. So when we iterate through this string, which is a characters array, then each element that we actually receive with each iteration is actually a char, and you can see it here. So we have here a char, letter is a char, but we can print chars in the console because Visual Studio and C# and .NET actually knows exactly how to do this. So in this case, we can see that we wrote everything on a different line, but we can simply also change that and console write instead of writing everything on a single line, but now it will be written probably here. So we see the value of the string. Now, this is important because we have written this string on the console, not using the variable, which we of course can, but we have done this by iterating through that specific string with a for each loop. And it's exactly the same if we want to use a for loop. Sorry for that. That was not okay. So for, and in this case, let's have int I starts with 0. We want to go and iterate over and over again until we reach, or until I is less than string1.length, exactly like we would do in an array. And once again, let's have a console write line between them to have everything on different lines, and just console write. And in this case, what we want into the console, we can access right now the element by the index, and we have I that could be used as an indexer here. So it would be str1 and the index I. And if we run this application, it should do exactly the same. Once again, because in this case, just like we have seen in the case of the array, we can use this for loop and use I as the indexer to access each element on that specific string. Now, let's put in here another console write line to have a blank line between what other things we want to do. And then the next thing that we want to talk about, because this is a very, very important concept, it is the concept of string equality. And this is a task that we have to do actually in each type of application. So no matter what application you're writing, you will most certainly have to compare or to check if two strings are equal. Now, what does actually equality mean in case of a string? So let's also here create a new string. String, let's call it str2 equals, and this one it would also be hello world, but written in the way that we would normally write it. So it would be hello world. So let's try to do the next thing. Let's have here an if, and let's have if string1 equals string2. So in this case, we want a console write line, and let's write here strings are equal, else console write line strings are not equal. Okay, and let's run this application. Let's check the result, and we see that strings are not equal. So you might ask yourself, why are these strings not equal? Because we have here hello world, and we have here also hello world. So those strings should be equal. And here comes, well, the tricky part, or one of the trickier parts when we work with strings, especially when we are at the early stages of our career. And this is that string or the characters actually are different, even if they seem to be the same for us. So what does this actually mean? It means that what happens behind is that for each character, we have actually a certain Unicode representation of it. And this means that we have actually two different characters. So L uppercase is a different character than an L lowercase. So in this case, it means that this L here is not equal with this one here. And the same thing for this O, this one and this one, they are actually two different characters. They are not the same. And that's why when we do this very, very normal comparison, so we compare for equality string 1 and string 2, and we get the result that the strings are not equal. And this is correct because, as said, the characters are not the same. Even for us conceptually, they represent exactly the same message. For a computer, these strings are different because each character has a different character code. And here the uppercase O is not the same as the lowercase o, and hence these strings are different. So whenever you want to compare strings, and this is a very important thing because when you usually compare strings, those strings usually come from from different systems where they were inputted or they were input by the user by hand. And in this case, of course, you cannot expect that each user will write the exactly same string in the exactly same way. So in this case, one common thing is that we could do is that we, instead of comparing the strings as we get them, just make everything lowercase. And this is very easy to do because we have here a method on the string which is toLower. And then also toLower. And in this case, when we run the application, what will happen is that, well, our strings will all be made lowercase. So all the characters that we have here as uppercase will become lowercase. So in the end, we'll end up having in both cases strings like hello world like this. So that would be the one. When we use toLower, then this would also be hello world. And in this case, you can clearly see that the strings are equal because all the characters are exactly the same. So if we run the application right now, the result should be totally different. And in this case, strings are equal, which is correct because we have lowercase our strings in order to be able to make a better equality comparison. Now, there might be things, for instance, or scenarios when you use different type of character sets that also are specific to different cultures, for instance. And in that case, once again, each character from a different culture has a different character code, even if for us it seems actually to be exactly the same character. So this means that strings will not be equal even if we use this toLower. But in this case, what we can have is another method on the string, which is toLower invariant. And here, if we look at what this method does, it returns a copy of the string object converted to the lowercase to lowercase using the casing rules of the invariant culture. So it tries not to be specific to a certain culture. And then we can also make this toLower invariant, and then everything should be fine. So if you're working with strings that might be represented in different cultures and you want to compare them, then or check them for equality, then it might be wise actually to use this toLower invariant method. But usually, if you work with strings that are actually or don't expect to mix up different cultures when it comes to the strings in your application, then of course you could also or even use the toLower method. There is also a toUpper method, of course. If you want to transform all characters in uppercase characters, you can use that as well. However, once again, as the conclusion here for comparing for equality or looking for equality of two strings is, once again, that we need to make sure that we have both of the strings that we actually try to compare for equality using the exact same casing. So in this case, we transform them both to lower. So in the end, we get something like that. Now, okay, let's go one step further. And the next thing is, at a certain point, you also surely will be in a scenario where you want to perform a string comparison. Now, the difference between string equality and string comparison is that when we check for equality, we actually try to determine if two instances of the object are exactly the same. So we kind of like just want to compare two objects and see if they match. But when we talk about comparison, we actually do this when we try to actually order, for instance, several different string objects. And most of the objects in C# have different comparers that can be used in order to check for comparison. And this is actually, for instance, if we would have several strings like, for instance, one that starts with A, another that starts with C, and another that starts with G. And if we want to make sure that they are placed in the correct order, like the alphabetical order, we need to compare them. Of course, .NET has a way to do that, but in some cases, we might want to be able to compare strings and create kind of like a sort order for a sequence of strings. And in that case, we can actually use the following method that we have on the string class. So let's have this variable, which is int result, and we will see exactly why just in a few seconds. And this result is equal string, and here we have compare. And here what we can do is we can compare string 1. We want to also use string 2. And then we can specify an optional parameter in which we specify if we should ignore the case or if we shouldn't ignore the case. So if, for instance, we use here true, it means that ignore case true. So we ignore the casing of, and here it's str2, sorry. So this means that we ignore the casing when we try to create actually a sort order for the string. And when we use the compare method, let's just take a look here. And here it says exactly that it returns an integer. And here we have some very important things to note. And this is the basic of comparison when we do this in C#. And we'll probably have a total different lesson on implementing comparers, or when we want to compare our own objects based on our own logic. So to define, okay, which, I don't know, car might come before another one or after one or on the same position in the sequence. And then we have to implement this type of compare method. And the logic of this comparison that we have here is that it will return less than 0 if string A precedes string B. So if the string A comes before string B, it will return 0 if string A comes exactly on the same place in the sort order as string B, or it will be greater than 0 when string A actually follows string B or comes next or after string B in the sort order. So this compare method, as we see here, returns an integer. That's why if we print it in the console.writeLine, let's print the result and see exactly what we have in this case. So once again, here we have hello world, but we have it here in different characters. But we see here 0. As we have seen, 0 means that we should ignore casing. And this is because we have specified this through here. So it means that when it did the comparison, it actually compared this to 1 here. Not what we have here, but what we have here to lower, let's say. So it means that they compared each character on the same casing level, let's say. But then if we change this here to false, then if we run the application, I guess that the result should actually be different. In this case, it is 1. And this means that in the sort order, and this is the default sort order that .NET implements, means that string 2, so this string here, comes after string 1. So if we would now need to sort those strings in this order, then the result would be that string 1 comes first and string 2 comes next. And yeah, that's it about this, how we can actually compare. Okay, another thing that we can do here is, or on strings, and this is a very important behavior or method that we have on string, index of. And this is actually, as said, shouldn't be something really new, because we have talked about this when we discussed arrays, and we have we saw that we can actually try to find out for a certain element on which index it actually resides. So here, for instance, we have int index equals string 2 string 2 index of, and here we can specify a certain character from the string. So I would let's start with the age. Okay, and then let's console write line this. So console write line. Let's see the index of age. So once again, we look for the letter age in string 2. And let's see on which index do we have this letter. So let's run this application. And we see that we have here -1. And you might ask yourself, okay, but why do we have -1? And once again, I come back to the same story. It's because here we have specified age, which is lowercase, but in string 2, we have here age, which is uppercase. So in this case, the characters are not the same. So in this case, it means that when we look for this element, we actually don't find it, because it's actually not here in this char arrays. We have no char that is actually a lowercase age, and that's why we get here -1. Now, for instance, if we get here, or no, let's change this, and if we get here age, so this is the uppercase. In this case, I would expect that the result in this case should be 0, which is correct, which means that this letter is on the index 0, which is actually the first element in this char array, and this is correct. Now, another thing that we can do here is, let's have another one, int, let's call it index 2. Also, let's do this on string 2, index of. And another thing here is, if we specify here double L, let's see what happens here. So console.writeLine, and let's write index 2. But here I have a typo, so it should be fine right now. So let's see what happens here. And here it won't compile because there's a backslash here. That shouldn't be. Sorry for that. Now let's run it again. So in this case, we can see here that we have that on index 2. So what it actually happens is that if we provide a sequence of characters, it will look actually to find that exact sequence of characters here in the string, and it will give you the index of the first element in the sequence that you are looking for. So we see that it was 2 because this first L, this is 0, this is index 0, this is index 1, and this is index 2. So the first element in the sequence that we were looking for was on index 2, and hence they give us the result for the first index where this exact sequence starts, which is very, very important. This is a way that you can actually look into a string for different characters and of course then perform further actions on them if you want to. Maybe use the indexary in order to, well, do something with that element on the specific index. Good. Another thing that it is important with string is escaping. And that's a really, really important topic, because when you write your programs, you very often will have to work with file paths. And a file path would be usually something like C, or this would at least be in Windows like that. It would be something like C, colon, then backslash, and then, I don't know, users, then maybe I have a user called code wrinkles, and things like that. And here I could have a program.cs file. So this is how actually a file path would look like. However, there is a big problem here, and we see that we have a lot of red squiggly lines. And the problem here is that there are certain characters that we actually use, or that .NET and C# uses actually to do some other stuff. Like for instance, if we use actually these quotation marks. Quotation marks in C# are used actually to delimit a string literal or a string. But what if, for instance, we want to print in the console these quote lines? So we wouldn't be able to do that. If we want to do it like this, you see, once again, we have a lot of problems. The same thing is that C# and .NET uses backslash a lot of times to perform different types of formatting, especially when you are writing things on the console. So in this case, what it actually tries to do is it tries maybe to do that type of formatting. So in this case, it means that we would have to do something in order to make sure that we can have correct file paths, of course, that are printed in the console, and or in regular applications, so that we can read files from them and then perform things on those specific files. Now, the idea is that we would have actually two ways, or at least two ways that I want to discuss right now to achieve this. So first of all, we need to escape these characters, and we escape these characters by actually placing another backslash before them. And it means that this backslash here escapes the other one, and it actually indicates that, hey, if you see here this one, and then you have another backslash, then this backslash should of course be written as a regular backslash. And here we could do exactly the same thing, and we see that everything should be fine right now. And here we could do exactly the same thing. And if we console.writeLine, if we print this right now to the console, let's have a file path to the console, we will see that the result will actually not contain two backslash, but only one. So it is a correct file path. And this, once again, is called escaping. So we use the first backslash just to indicate that what comes afterwards should be represented like a literal, like the character that it is right there. So in this case, we just have one backslash. So how do we resolve here this problem if we want to put this file path in quotation marks and we want it to appear it this way in the console? Well, quotation marks, as said, are used in order to identify a string literal, but if we want to just print them on the console as a regular character, we just can escape them. So we place a backslash before it, and we place a backslash before this. And in this case, it means, hey, if you see here this quotation mark, since it comes directly after this backslash, then represent this as really regular quotation mark, not like a string literal, because this is actually what we need. So we have escaped also our quotation marks here. Therefore, the result when we run the application will be that this file path will be printed in quotation marks here on the console. And once again, this is called escaping, and we can do this using these backslashes here. Now, let's assume that we don't want to write here the quotation marks. So let's also remove the escape sequences that we had here. And I would just want to show you another way in which we can achieve that. So another way in which we can say, hey, just escape all the characters that need to be escaped, we can just specify here an @ sign just before the string. And in that case, it's exactly the same. So the result would actually exactly be the same as we would have written here 2 backslashes each time. So it's actually exactly the same thing, only that in this case, everything is, I would say, a little bit more readable. Once again, if we run this application, the results should exactly be the same. We see it's exactly the same like it was before, but in this case, we did not have to really escape this because we have placed this @ sign here, which indicates that all characters that needs to be escaped should be escaped. And that's actually it. Good. Now, another operation that we might need to perform very often is to actually extract substrings from a string. Like for instance, I just want to extract the name of the file. In this case, it would be this program.cs. So I would just want to print in the console this program.cs. But of course, I want to do this programmatically because I might read this file path from somewhere and I just need to extract the file names from them. So how can I do that? Well, that's actually very, very easy. It's not complicated at all because we have a substring method. But before we do this, let's count how many characters do we have until we actually start the file name. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So let's do the following thing. Let's have here, for instance, string sub, which is, or let's call it file name, and it would be file path. And here we have this substring method that we can use. And the substring method can be used actually very, very easily. We can just specify at which index do we want to start. In this case, we said that we want actually to start here at the index 23, and then place everything which comes after that index on another string, which is the file name string here. And here, let's also write line this to the console. It would be file name, and we'll see just in 1 second if I have written everything correctly. And it's without the p, so we have to start just 1 index earlier, which would be 22, and that should make it then. So in this case, we have extracted a substring from a certain string. But we can also, for instance, with the substring, we can do things like this. Let's say string sub equals file path, of course, then substring. It's exactly the same method, but there is an overload for that. And let's say extract me a substring that starts at index 5 and goes for 3 characters. So this would extract something like 1, 2, 3, 4, 5, and goes 3 characters. So it would be SER. So this would extract only a substring that is that starts at index 5 and goes for 3 elements. So let's also write line this. Be sub. Let's see if it's correct. But even if I didn't count correctly, but it's ERS, which is correct. So it's exactly what happens. It's ERS. So we start at index 5 and then go for 3 elements. And yeah, this is how you can extract smaller substrings from the middle of a string, for instance. And that this is also one important thing to know. Now, another thing here, which is something that you'll do very often as a developer, is, well, checking for nulls. And as said, the string is a reference type, and therefore strings can be null. So we could have here str4 which is null. Now, if this string is null, we want to print on the console the string is null, like using words. And if this string is not null, then we just want to print at the console string is not null. So one way to do that, and that would probably come very natural, is to say here, for instance, if str4 equals null. In this case, console dot writeLine, and as said here, we want to say string is null, and else we want to console writeLine that string is not null. Okay, and this should actually work. So if we run the application, we see that here string is null, which is correct. But for instance, if I do the following thing here, and this is another very important stuff. If I write here string.empty, that would actually create an empty string. Once again, a string can be null if we don't have an object, and basically we don't have a reference to point to a certain object on in memory. So in that case, we have null. But if we have an empty string, we have an object, but we don't have any characters in it. We just have an empty array of characters. So in this case, if we run the application, of course, that the result will be that the else will be printed. So string is not null. Because, yeah, okay, it's empty. So if we want to write the string in a console, we wouldn't see anything, but it's actually not null. It's just empty. And this is really, really important, because often you would be in the case where you could get null strings, and then this check will do. But in this case, if the string is empty, well, for you, as for the logic of the application, you still don't have anything to show. So this means that you usually, when you want to check for null, you also usually want to check if the string is empty. And in that case, of course, we could do here a nested if statement, but of course, this seems not to be a very good way to do that. And here, the good thing here is that we have on the string class a method that does exactly this, is null or empty. So if is null or empty str4, then print me this in the console. Is null, let's also add is not null or empty. So once again, it's important whenever you want to check if a certain string is null, you usually always want to also check if the string is empty. And in that case, you just always use this is null or empty method. Let's run the application, and it should actually do exactly the same. So we have here the string is null or empty, because guess what? We have an empty string here. And the same we could do, okay, let's have here this one. So if you run this application, we just have a white space there. And here, of course, the string is not null or empty. Now, in this case, of course, this is correct once again from a very, very technical programmatic point of view. This is totally correct, because here this string is not empty because it has a white space, and of course it's not null. So in this case, of course, that we hit this else, and then we display that the string is not null or empty, which is correct. But once again, from a usability perspective, usually when you work with strings, you want to show them to the user, or to provide them to other applications or to other components of the application. And in this case, if the string contains only white space, it's not something that it might be worthwhile to actually show further. So to accommodate also a scenario in which we can check if the string is null, if the string is empty, or it contains only white space, we have another method which is called is null or white space. And even if the name says that it is null or white space, if we hover the mouse here, we see that it indicates whether a specified string is null, empty, or consists of only white space characters. So once again, if you want to check if a string is not null, is not empty, and doesn't contain only white spaces, then you have this is null or white space method. So that's why in most common scenarios, when you want to make this check, you will probably want to use this method. So to make sure that you have a string that really contains real characters, not only white space, it is not an empty string, and of course, it is also not null. And yeah, that's actually most of what I wanted to discuss with you when it comes about strings. As we have seen, strings seem to be very, very simple, but there are a lot of different caveats that happen or that we might fall into when we start to work with strings, starting from the how we compare them for equality, how we compare them for establishing a sort order, how we can, for instance, deal with null or empty or white space. And then we have seen also other common tasks that we can perform on strings, like extracting a substring and also other things like that. So strings seem to be very, very simple, but I can assure you that you have to pay a very special attention to them, because you might fall into different traps that you are not directly aware of when you start to work with strings. So this being said, thank you very, very much for watching. I hope you learned something from this new lesson, and until the next time, I wish you the very best.